Okay, this is going to be 85 to 91, and I think I'm going to have to split this up into two parts because just looking over this, it's going to be pretty long. So we'll start with number 85. It says to avoid a sand trap, a golfer hits a ball such that its height is represented by the equation h equals negative 16t squared plus 80t, where h is the height measured in feet and t is the time measured in seconds. Okay, so right away, my biggest inclination is to say, okay, well, I want to kind of see what this is going to look like when I graph it, because I want to make sure, number one, that I'm doing this a little correctly, but I'm just kind of curious. What is this going to look like when you graph it? So negative 16t squared plus 80t, right? Where's t, or x, actually, I should say. And when we graph this, whoa, okay, well, that's not very helpful. So we might need to change our window. So let's change our window to, I don't know, negative, well, we'll just leave it at 0. And x max at, let's go with 20. And then we can scale it by 5. And then we can do, I don't know, negative 20. And y max at, I think this is going to go pretty high. I don't know, so let's try 50. And then y scale by 5. Let's graph this. Okay, so, we got to move it over a little. Okay, so x max at 10, scale by 5. Oh, okay, so it's even higher than what we said. Okay, so let's go to window. I know this, I'm playing around with this, but I really want to see what happens here. Y max, let's try 100. We'll scale by 5, still, see what happens. And then, let's graph that. Hey, there it is. Okay, so we know the ball starts at 0, right? It goes into the air, comes back down again. So it goes into the air, comes back down again, hits the ground. And then it hits the ground, it looks like, what did we change the window x max to? 10, right? So why don't we change it to, still leave it at 10 and do it by 1s instead and then see what happens. Okay, that's a little bit better. Hey, that's pretty good. So it goes up. The highest that I made it on the y-axis was 100, so it goes pretty high up there. Comes back up, comes back down again, and then it looks like it hits it around 5. Okay, so this is what it looks like. The only problem is you don't really have this at home. You have it on the video, but you don't really have it at home unless you have a graphing calculator at home. So how do you do this without taking advantage of your technology? So, to avoid a sand trap, if golfer hits the ball, right? So we know it's, first of all, it's negative. So we know at least at some point that it's going to go up and then it's going to come back down again because it is a negative parabola. Oh, that's a horrible graph. I'm going to redo this. Okay, that's better. Okay, so that's the path of the ball. I'm only going to limit it to this because technically the domain restriction, it's not going to go underneath the ground unless it's, you know, coming up from space. And it really started at 0 from where you hit it because it was, the golf ball was on the ground. It goes in the air, comes back down and hits the ground. So, I mean, the graph on here may be a little bit different, but the reality is the ball isn't going to go underneath the ground. Right? It's just pretty much going to stop when it hits the ground. All right, to avoid a sand trap, that's the equation. When does the ball land on the ground? So we really wanted to find out when does it, we know it hits it off the ground at 0 and then comes back. So the question is, what is that right there? Well, when you think about it, this is your x-intercept. This is your other x-intercept. So if you just find the x-intercept for that equation, you should be able to figure out when in time does it actually hit the ground. So the way that you would do this is, okay, well, the height when it hits the ground is at 0 because it's on the ground. It's not off in the air at all. So height would be at 0 is equal to negative 16. Time we want to know. squared plus 80 time. So we need to solve it. Okay, well, right now, there's no way to solve it unless you factor it. So factoring would be taking out what you have in common and setting them both equal to 0. If you're looking at this, I think somebody in class today said something about using a quadratic formula. And I said, yeah, that's perfectly fine. There's no reason not to. I mean, it's a little bit harder because you have a lot of big numbers to work with, but it's still doable. So if you really wanted to do a quadratic formula, you should be able to get, okay, well then you'd have to do, okay, well there's no number here, so it'd be like plus 0. And then you say, oh, okay, well then negative 80 plus or minus b squared. So 80 squared minus 4 times negative 16 times 0 all over 2 times negative 16. Okay. All right, well, quadratic formula it is. There's this, right? Or you can factor. Factoring would look like I'm going to take out what I'm going to take out a t first of all, and then negative 16 and 80. Do they have anything in common? Is 80 divisible by negative 16? Or divided by 16 in general? Hey, it is. Okay. So I'm going to take out negative 16t. And I should be left with t minus 5, because negative 16t times t is negative 16t squared. Negative 16t times negative 5 is positive 80t. And then you get two things, you can set them equal to each other. So negative 16t equals 0, or t minus 5 equals 0. And then you get t equals 5, or t equals 0. So time is 5, time is 0. Now, if you do quadratic formula, you should still be able to get the same thing. It doesn't matter which one you do. This goes to 0. Anything times 0 is just 0. So 80 squared divided by negative 32 equals negative 80 plus or minus. What's the square root of 80 squared? Well, that's just 80 at that point. Divided by 32. So x is going to equal negative 80 plus 80 divided by 32, which is just 0, or x is equal to negative 80 minus 80 divided by 32, which is actually going to give you your 5. Oh, sorry, was that negative 32? I dropped a negative. So this is going to be positive x, and x is going to be 0. Either case, it doesn't matter which, you get time, sorry, I used x instead of t. You get time equals 0 or time equals 5. So that means at 5, if you go back to your parabola, when the golf ball is in the air, at time 5, I'm assuming seconds. What was it? Oh, measured in seconds. So at 5 seconds, it's going to come back down and hit the ground. Okay, so when does the ball land on the ground? Okay, in 5 seconds. There you go. What's the maximum height of the ball during its flight? Oh, well, we have the equation, so this can work in our favor. So if it lands at 5, that means halfway through is 2.5 seconds. So if your x value for halfway through is 2.5, then plugging it back into the equation should give you how high the ball goes. So at height, the height is going to be equal to negative 16 multiplied by, so we found that it was 2.5, right, in the middle, because we want to know its maximum, squared plus 80 times 2.5. Okay, so the height is going to be equal to, I don't know, you figure it out. You're going to have to figure out what the number is, and I'm pretty sure it's going to be a high number. So from the looks of the graph, I mean, I scaled this at 100, so you got to be somewhere probably near 100, if I'm not mistaken. Okay, so what domain makes sense for modeling this situation? Meaning, what values of x, or in this case, time, makes sense for modeling the situation? So it's just basically asking you, would it make any sense to talk about negative time in seconds? And the answer would be no, because it doesn't. I mean, negative time doesn't have anything to do in this problem, because you hit the ball, time started rolling, and then 5 seconds later, you know. So technically the domain, what I would say the domain would be somewhere between, for time, it would be between 0 and 5 seconds would make sense. Okay. All right, so that was 85. You can see that we just spent 10 minutes on 85, so you can see the rest of this is probably going to be, well, we'll see how it goes. Is there another parabola one I can just put together with this one? Complete the square, write it in graphing form. I don't know about that. Okay, so, all right, I'll just go in order. Okay, I'm going to skip to 86 is long. I'm going to skip to 87. I'm going to come back in another one to 86. So 87 is solve each inequality below and graph your solution on a number line. So I'm going to do the first one. The other two you should be able to handle on your own. So I'm going to remind you what the setup was. So you take your equation. You do b minus 4 squared is equal to 12. Okay, and you solve for b. So there's a long way to do this and a short way to do this. The short way would be, since you already have the whole expression isolated with the square, then you can just take the square root of both sides and get b minus 4 is equal to plus or minus the square root of 12, whatever that might be. And I'm pretty sure that's, I'm just going to leave it as square root of 12 for right now. And then, so you have b minus 4 equals the square root of 12, and then b plus 4 equals the square root of 12. Okay, and that should give you two answers for b. And then on the number line, you need to put those two answers down. One of them is going to be, I'm pretty sure, positive. The other one's probably going to be negative. And you need to, you have an open circle. So one of them is going to be open circle. The other one's going to be open circle. And then you need to test 3 regions, if it's true or if it's false. So pick 3 numbers, 1, 2, 3, whatever the regions are, and then plug those back in for b, each separately, and see, does it give you a true statement when you plug it in? So if you, let's say you plug in 0 for b. 0 minus 4 is negative 4. Negative 4 squared, in parentheses, is positive 16. Positive 16 is not going to be less than 12. So if you use a 0, it's going to be false wherever the 0 is at. And then you have 2 other points that you need to test. And then as your final answer, needs to be written up as an inequality. So, oh shoot, you know what? I think I need to do this because we're going to have issues if I don't do this inequality. Okay, what is this? The second square root of 12 plus 4. What is it? 7 point. Okay, I'm going to round to 7.5. It's going to be bad, but that's okay. 7.46. Okay, let's do that. And then second square root of 12 minus 4. Okay, so it's going to be around negative 0.5. What? 53? All right, we'll leave it there. Okay, so one's negative 0.53. The other one is 7.46. I already tried 0, so I know that doesn't work. So it's going to be false over here. So there's your open circle, open circle. So if it's false in the middle, it's probably going to go up in both directions like that. So that means B is going to be less than negative 0.53, or B is going to be greater than 7.46. Yay. And B and C are supposed to be done the same way. Okay, now I'm going to stop here and then do the second video.